Hello everyone, we're looking at question 6 of winter 2018 paper 139702. The question reads, a stone is projected horizontally at time 0 and falls. Air resistance is negligible. This is an extremely important piece of information. Air resistance is negligible. The stone has a horizontal component of velocity Vh and a vertical component of velocity Vv. Which graph shows Vh and Vv vary with time? Let's try to visualize the trajectory of a stone. This is a stone and I'm standing here and I just throw this stone straight right. Now, eventually, obviously the stone will not keep on traveling in this direction. What stone will do, it will just follow this trajectory. Now, so this is, if I were to dissect its trajectory, this will be our Vh and this will be our vertical velocity. Now, if it is going in this direction and there is no air resistance that is sort of hindering its motion, it's going to have a constant Vh, because if the stone is going in this direction and there is no opposing force that's hindering its motion, it will just keep in this direction. It will have a constant Vh until it lands on the ground. So we can say that Vh velocity will remain constant. So we can cut this out because it's showing vertical velocity as constant, which we just said no. So we can have to find out the answer from these three. Now let's take a look at the vertical. Now we know it will come in this direction, and so this is our vertical velocity, right? Now again, as it's going down, there is no opposing force like air resistance that is decreasing its resultant force. We know one thing for sure, that every single time you throw something from a height, the moment they start their journey of landing down, at that very moment their acceleration that is 9.81. At that very moment their acceleration is 9.81 and the entire resultant force is acting in this direction. But eventually, as air resistance acts up, this resultant force starts decreasing, and so what happens is that this is a stone and initially it was 9.81, and if there is air resistance, if there is any resistive force, what happens that this starts decreasing from 9.81 to a value lesser than that, and this force starts decreasing. However, in this part they have mentioned that air resistance is negligible, which means that this 9.81 force will remain constant throughout. So this is our acceleration, but they haven't given us acceleration. One thing I have said so many times is, whenever you get graphs, look at their axis. Look at if their gradient can give you anything. We know velocity over time gives us acceleration, because acceleration can be defined as a rate of change of velocity. So its gradient can give me acceleration, and I just established the fact that acceleration remains constant, so its gradient has to remain constant. So in which of these three, out of these three, is the gradient remaining constant? Just this one. And so your answer is A.